So sometimes you need to treat an object as though it were another kind of object. For example, why do we have to print their name out here if we had this other function we could do? What we could do is go back and modify this print student one to say print this student as though he were a person. And then we could change this to print out s.degree and s.school, since that's the new stuff. So what this is doing is we're using casting to say, well, we're not going to treat you like a student. We're going to trick the compiler into thinking that you are a person, which is fine because a student is a person. Then when we call print, it looks for the closest match, and the closest match there is one that accepts a person as a parameter. Prints out the name and the birth date. So it's going to print out the name and the birth date, then it's going to print out the degree and the school. Can I close this, please? Anyways. So now let's run that, make sure its behavior has changed. There we go. So Joe is just a person. We print that. Sam's a person. We called his print method using that cast, but we also printed out his additional information. So that's the idea of using casting to convert from one object type to another. If we're given a person and we think that it might be a student, there's a function we can call to see if a person is a student and then base our behavior on that. And I believe that's in the PowerPoints, but I'm going to leave that alone. So now I think in order to talk about abstract classes, we really should have two subclasses rather than just one. So we're going to implement one more class. So we're going back up to our classes that inherit from person, and we're going to make this one called employee. It also extends person because not every employee has been a student. Otherwise, we could extend the student class. And this is a subclass, so I'm going to go ahead and denote that. And what's different about an employee is that he has a job. Hopefully. There we go. Now we have two classes. We have two subclasses. Much like our picture here where we had three subclasses from the bicycle class. Let's go create an employee down here. I'm going to do that just right up here at the top of main so I can keep the employee class on the screen. Employee E1 is equal to new employee. E1 dot name is equal to Sally. E1 dot birth date. I think what October 20. Wait, no. October 28th, 1999. And what attribute, what variable does employee have that a person does not? Job. So job is equal to programmer. What happens when we try to print that person out? Which print method is it going to go to? Is it going to go to this one? Or is it going to go to this one? We don't have a print method that accepts an employee as a parameter. So the compiler hooks it up with the nearest match, which is person. It can't be student because an employee is not a student. We didn't extend the student class, but we extended the person class. So an employee is a person. So when we call this print function, it's just going to run up here and print the person. So all we're going to see is their name and their birth date, nothing else. We probably ought to overload another print statement in order to print out their job. But there we go. Sally doesn't have any extra information because it went to this one. That all it did is print out the information of the superclass, the parent class, the name of the birth date. We could fix that if we so choose. Let's go ahead and put a print for the employee class. The first thing we want to do is print out that person information, so we're going to use casting to print out the employee. Then we're going to print out the extra information. That only an employee has, which is the job, e.job. I misspelled void here. There we go. So let's make a few more changes to this print function. I'd like to just add the word person, whoops, in front of this print string. And I'd like to add the word student in front of this print string, and the word employee in front of this print string. That way we just kind of see where we are. So Sally was our employee, so we ran print, it printed out Sally. It did that by jumping up here, and then we called the print statement by casting the employee as a person, so it ran up here and it printed out the person information as well. That's why we have two lines of output there. The next person we printed out was just Joe, who's just a person. He's not a student or an employee. So when we called print, it just jumped up and did this one. Did the print person, no extra goodies. Sam is a student, so we said his information, we called a print. So it looked for the overloaded method that most closely fits, which is the one that accepts a student. First thing it did is cast its reference to a person and invoke print, so that jumped up here and it printed out the person information, Sam and his birthday, and then it finished printing out the student information. Okay, so that's a little bit more about inheritance. I think that, let's show what happens if you cast something as something it is not. Here we have an employee class. But let's say that we thought we could change this person into a student and then run it. It's going to give us an error. It says incompatible types. Employee cannot be converted to student. That's because they are both subclasses. That'd be like saying, okay, I have a racing bike and I want to treat it like it was a tandem bike. You can't. Those are completely different classes. You can say I want to treat my racing bike as over a bicycle, or a tandem bike as over a bicycle, but you can't cast any one of these classes into any of the others. So I need to undo that change. So that's inheritance, an extension with superclasses and subclasses. So what's an abstract class? Well, an abstract method is a method with no body that has to be implemented by all the classes that inherit from it. So let's just say that we're going to come down here, and for student we're going to add a method called eat, and what that does is it prints out a message, system.out.println students eat ramen soup because they can't afford anything else. Here we go. And so then I think to myself, well, I sure would like to be able to print out what every person eats. So I'd like to come to this print method for people and do p.eat. That doesn't work. Why doesn't that work? Because the person class doesn't have an eat method. Only the student class does. So we think, okay, well, I'll add an eat method to the person class. Public void eat, and what do people eat? I don't know, maybe they eat pizza. System.out.println eat pizza. Now this will work, sort of. We're going to run it. We will see that even though we tried to print a student and print out what they eat, the student who was going to row state, okay, make a liar out of me, it did successfully call eat ramen. That's cool. It worked its way down the chain of inheritance to call the proper eat method. Sally is a person, so the only eat method available to it is the one that's part of the person class. I need to change these names a little bit so that we could, put that. I'm going to do that. I'm going to come down here, and the person is going to have a name that starts with a P. So Phil. This is just to distinguish them easily. The employee is going to have a name that starts with E, Eric. And the student's going to have a name that starts with S, Sam. Okay. That'll help keep track over here when I run it. So Eric, when we called eat, he eats pizza because that's what the person's class displays when we call the eat method. The employee, Eric, when we run him, he also eats pizza. And that's because the employee class doesn't have its own special version. So it inherits the eat method from the person class. Because just like you inherit variables, you inherit methods. Since there's no customized version of the eat method here, then it goes ahead and uses that one. But Sam, the student, when it calls eat, well, the student class really does have its own custom version of the eat method. So it prints eat ramen, whereas the other two did eat pizza. So that's inheritance at play. If you call a method that's defined both in the superclass and the subclass, it's going to run the one that's in the subclass. Notice there's a little warning here. If we click that, it does this. Add override notation. That's just sort of a comment. It's not necessary. It's not part of the Java language, but it's a comment that indicates that this particular function, the eat function, is overriding the behavior of one defined in the superclass, so that if a student calls eat, it's going to print this one out and not do whatever was needed to be done up here, which is eat pizza. And that's okay in this case. If you want to then go ahead and invoke a function from the superclass, you can do that with the keyword super, but we're not going to mess with that. That's what that little warning is. And if we have been implementing two string methods, you may have been seeing that override keyword popping up already. Okay, so what is an abstract method? An abstract method is one that is not defined, it's just specified. Public void drink. Like that. It looks like an interface from C++. It has no body. So what do we do? Well, that's an error. Maybe we can add the word abstract to it. Yeah, that fixes that error. But now it's complaining about the class person. And the deal is that once you add an abstract method to a class, the entire class is now abstract, or it needs to be. So to get this to work, I'm going to have to add the word abstract there as well. Then when I fix that, a whole bunch of other errors pop up. Yeah, so we've broken the code by doing this. Typically, when you design your abstract classes, you want to design them as abstract from the get-go. But we didn't do that, but that's okay. So what is this error complaining about? It's saying the student is not abstract and does not override the abstract method. So there's two ways I could fix that. One is I could declare this is abstract, but I'm not going to. The other is I have to add a drink method to this class. So this abstract method here must be implemented in subclasses. That's what abstract is an abstract method is one with no body that you have to implement in non-abstract subclasses. So, okay, I want that error to go away, so I'm going to do that. Public void drink. It has to have the same, definition. But we are going to put a body for it. system.out.println, what do students drink? They drink Mountain Dew or coffee. We'll leave it Mountain Dew. I put the semicolon in the wrong place. Okay, that fixed the errors for the student class. The employee class is still complaining. Employee is not abstract and does not override abstract method. I could make this one abstract, but I don't want to do that. The reason for that is once you mark a class as abstract, you cannot instantiate an object of that type. Down here where I created a person, I'm not going to be able to do that anymore. This is an error. The person class is abstract, so we cannot create an object of type person. We're going to have to comment him out or make him an employee or make him a student, but he can't not be a person anymore because a person is an abstract class. But let's go ahead and fix the employee class. We will add a drink method to the employee class as well, but employees don't drink Mountain Dew. They're grown-ups. They drink coffee. There we go. Notice we're still getting all these little comments over here. It's wanting us to add the override notation to them to get those warnings to go away. But you don't have to. It's optional. It's just if you like getting rid of all the yellow comments, you know, on the side of your NetBeans, you can do that. I'm going to undo that because I think it makes the classes uglier. Okay, so we have a eat method that we're calling inside print. We're also going to call the drink method. And if we call drink and that person is an employee, it's going to print drink coffee. If that person is a student, it's going to print drink Mountain Dew. The code is almost fixed. I see that one error down here. That's the fact that this person, we cannot create a person of that type of class. So I'm just going to comment the person out rather than make him an employee or a student. Just comment that one out. Okay. Now when we run it, Eric, the employee, he eats pizza, he drinks coffee, and his job is a programmer. Sam, the student, eats ramen, drinks Mountain Dew, and is a student of programming at Rose State. So that's what an abstract class is. An abstract class is one that defines a method that has to be defined in all the subclasses. You can mix in an abstract class abstract methods and non-abstract methods. If I wanted to, I could put in a non-abstract method here, you know, rest. And everybody's going to rest the same way. They're just going to print out sleeping. That's okay. We have a method here with a body as part of the abstract class, and we have a method here without a body. The one without a body we had to mark as abstract, and that means that it has to be overridden down here. We had to go ahead and put in a drink method. This eat method here still has a body. That means that you don't have to implement an eat method. The employee class, for example, does not implement an eat method, so it defers to the behavior of the superclass, which is to always print pizza. That's why the employee eats pizza. I'm going to take that sleeping one out. Okay. So, in C++, you have the idea of a pure abstract class. And a pure abstract class is one with no non-abstract methods. Java calls that an interface.